till last class we saw what were header files, what were pre-processed directories, what were executable statements, and we also saw how memory is stored and how much memory, I mean, like how memory works as such. We also saw the different data types in C, namely int, shortint, longint, char, and then float, long, double float, and then there was another float data type which I don't remember. Cool. For today's session, we're going to do something called, we're going to learn about something called operators. Okay. This is the online IDE which I will be using for this session, and I have posted a link in the chat also, so that you can follow along if you would like to. Starting with, just am I audible and visible?
Yes, Aditya.
Oh, great. And if I'm looking too much to the side, that's because my notes are here. So yeah, don't be bothered by that. Thank you. Okay, starting with the very basic. Okay, that is called uh, that is operators, and we'll start off with assignment operators. One of the most basic and fundamental operators used to write logical expressions is assignment operators. What it does, it literally assigns a value to a variable. Syntax will look something like. Syntax is the word which I'm referring to the grammar of whatever operation I'm doing. So first we'll have to declare a variable and call that, and we'll call that A. Uh, Variable is nothing but address to a memory location. I had gone in detail about this in the last class. And then I'm going to say A is equal to 3. Now what happens is the value 3 is stored in A. Since I've given int A, it will allot 4 bytes of space to the variable A, where 3 will be stored in its binary form, because binary is what computers understand the most. And so basically that's what uh, it does. Okay. And then moving on, we'll go to arithmetic operators. I'll come back to these later, because for that we'll have to understand arithmetic operators first. Arithmetic operators, as such, are also called as binary operators. Um, okay, okay. So arithmetic operators or mathematical operators, as such, are also called as binary operators. Why you may ask me? Because there is a requirement of two values to perform these operations. So let's say a plus b or 1 plus 2. You need the value 1 and you need the value 2. So when you add them both, you get uh, what to say? You get a result or a value. So that's what they're called the binary operators. And then so to explain, add, subtract, multiply, and divide is something you are familiar with. Modulus, it takes the remainder of the uh, oh, like let's say 10 modulus 2. I will show it to you. I think that's better. And now I'm going to say printf. Printf is the command to uh, um, print it to the default output device, which is the screen in this case. And I'm going to say 10 percentage 2. Now you have to first literally do it manually. You'll have to divide 10 by 2, which is 5, and the remainder is 0. So the result of this expression will be 0. We'll see that also. Oh, sorry. You have to choose the language. I didn't do that. Yeah. So the result is 0. Now let's say 11 by 2. Now when I divide 11 and 2, uh, my answer will be 5 will be the quotient and 1 will be the remainder. So when I execute it, 1 will be the remainder. Is it clear till here?
Yes.
Moving on. Okay, so these are called binary for a reason, just because they require two values to operate. Then there are something called as unary operators. There are something called as unary operators. Unary operators, as the name suggests, requires only one value to operate upon. Okay. Now, Let's have a statement 1 plus plus. Okay, this won't work. Mm, Instead, we'll do something else. We'll declare a variable a and say a is equal to 1. I'm going to show you a bunch of stuff. It's actually very interesting if you ask me. I'm going to say a plus plus. What is expected to happen is a is equal to a plus 1 is going to is expected to happen. So that is 1 is equal to 1 plus 1, which is 2. Keep in mind key mistakes here. It only increments by 1. That is something you have to keep in mind. If you want to increment it by 2, you can't use a unary operator. But then now we'll run this and see. It displays only 1. Why is that? That's because we are doing something called as post incrementing over here. We are incrementing it after wait. So plus plus is over here, and then the variable is over here. So what this percentage d does is it goes and fetches the value of a. Now as soon as it fetches the value of a, it goes and prints the value of a. But then after that is only we are incrementing it. So this is called as post incrementing. So you are incrementing it after whatever is supposed to happen. Now let's if we want to print 2, we do plus plus a. So what happens is first plus plus is executed to a, that is a is equal to a plus 1 is actually executed, and then it is printed, right? See, now we have our required answer, which is 2. We have to keep in mind the fact that only one it increments the thing by 1 and not more than that. It's always a equal to a plus 1. It's only 1. If you want to do it for more than 1 and you have to keep it short, I'll come to that. Okay, moving on. Relational operators. Relational operators as such are pretty straightforward. They are just greater than, lesser than. Okay, relation operators as such are very straightforward because they're just greater than, lesser than or equal to, not equal to. I mean, operators which you are very familiar with. But then the thing is, you have to keep the syntax in mind. Double equal to me only means equal to. If you give single equal to, that means completely something else. I mean, something completely different. It assigns value to the variable. So that is something we don't want to know when we are comparing to values or a variable and a value as such, right? Okay, and execute it in short. Let's say, yeah, this is a equal to 1. The value 1 is going to go and sit in a. Now if I'm going to say printf uh, percentage d a sorry, equal to 1, what do you think is going to happen? Anyone can answer.
I think it will print a after checking if a is equal to 1.
No, not exactly. Okay, I'll tell you. Now we run this, and the answer is 1. Okay, wait, we'll do something else then. This is not what I expected. Oh, it's still 1. Okay, so it doesn't work the way I think. I'm so sorry. Now we'll do an if step. If a equal to 1, in def a is equal to 1. Okay, now we are checking if 1 is the value in a. So that is the use of the double equal to. Okay, that's because, okay, we got an error over here because I didn't put semicolon after.
Semicolon.
Exactly. Pull that. No, like I'm actually interested. It wasn't Archit, so I want to know who.
I guess it was Sanjay.
Oh, okay, cool.
It's Bharat, bro, not me.
Bharat.
Oh, okay. Sorry.
No. It's Nakula Venkat.
Oh, okay.
Yeah, like we literally named everyone in the meeting. Okay. Yeah. So now we have given an if statement checking if the value of a is equal to 1. That is the use of this double equal to. So be careful when you're saying equal to and equal to. They change their meaning with context, not in English, but then in computer language.
Yeah, I had a doubt here actually. If in the statement here you have written if a equal 1, after that we don't need to give an inverted comma. It's not inverted comma, semicolon.
No, you don't have to give a semicolon because you have a block of statement to execute.
Okay.
If you give it over here itself, now what happens is that's all. This statement is over, so this thing will not be even be considered. So since you want it to be considered, you give a separate block for it, and then you write the statements you want to execute.
Okay.
Get the point?
I get it.
Okay, cool. So that is all there is to relational operators. Any doubts?
I had another thing in mind. Suppose we are multiplying. Okay. So suppose I put that printf plus a into plus a. Will it work?
Plus plus a into plus plus a. I don't know. I haven't tried it yet. We'll see. Plus plus a. I would like to give these in brackets. I'll tell you the reason why. Like it's literally the next topic. That will matter because I haven't put semicolon. That is still an error because okay. I gave a bracket, but then I did not give the other bracket. I opened a bracket over here, and I'm supposed to give two to close, nah. So I didn't do that. That was the issue. What was A?
It was 1, right? So it should be 4.
It doesn't work. You are getting a random value. So we'll
Or
just
is
Wait,
it
plus plus A or A plus plus?
say
it's plus a, Abhijit. If it's after a, then it becomes a post operation.
Okay. Basically, you want to increment A and then multiply it by itself. Right.
yeah, something like that. Yes. I'm not sure why 9 is coming exactly. Okay.
You're supposed to get 4, right?
Yeah, we're supposed to get 4. Let's do something else then. B equal to- We'll do the same operation in a separate variable, then try printing it. Now the process that I'm doing right now, I'm trying to get 4. I know the answer. I know the question. I'm trying to link the question to the answer. This is called troubleshooting.
Okay.
Uh, so yeah. Now we'll take this off and we'll print B. Okay. Oh, what was the mistake?
We didn't declare a B.
Exactly. Also, you should be patient while troubleshooting. Oh, another error. We are still getting 9. I don't know how.
Try instead of putting A plus plus A, like A plus 1, maybe A is equal to A plus 1, something like that.
Okay, we'll do that also. Yeah, now it's 4, but then why not be 4? Like, what's the difference between that and this? Okay, look into it and get back to you, Arjit.
No problem.
Now it's 2. Why?
Why?
Exactly, I don't know. I know I'm the tutor, but still, I don't know. Like, I never thought of this. Like, we're spending too much time on this.
Okay, maybe the unary operator, particularly in GDB might be messed up. I don't know.
Okay, we can check that, but then that'll take time. Like I can open VS Code and check it, but then that'll take time. I'll
And
get.
we will postpone it. We will postpone it to
Yeah.
some other day. For now, let's focus on the material today.
I have some basic questions. What is the
Go
use
on.
of that percentage D which you typed?
Okay.
Yeah.
Percentage D behaves as a placeholder for an integer value. Okay. I mean, C as such is a very basic language, so you will have to tell it everything. So by saying, do you have any Python background?
No, not really. No.
No, that's okay. Uh, Percentage D will literally do the work of telling C, I mean, telling the OS that while printing here, the value of a integer will come. Okay, now let's say um, I am a good boy. No, that doesn't make sense. The number of attendees. When I say the number of attendees, this is a constant, right? The number of attendees is something that I've given in double quotes, so it's constant. The moment I give percentage D, that means I'm taking value from A and putting it into percentage D. I
Okay,
mean,
all right.
putting it in the
Yeah.
place of percentage D.
Okay.
Now,
Yeah.
let's say we had some other text over here.
Hmm.
Still, A will be put in the place of percentage D.
Percentage D. Okay, so basically
Okay.
percentage D is nothing but substituting the value from the other side. Yeah.
You can't say it as substituting the value, you have to call it a placeholder. Because
Placeholder.
substituting the
Okay.
value will be very ambiguous.
Hmm.
Also, it depends on
Now,
what A is. If it's an integer, then the placeholder is percentage D.
I think you
exactly.
have logarithm background. Logarithm.
Uh,
Yeah, in
yes,
logarithm, we will use ambition symbol to print some other character. Here we use modulus of D.
Ah, yeah, we like add
In
the
logarithm, we will use
strings.
ambition symbol to print
ampersand, yeah,
any to print
exactly,
any character particularly. Here we use modulus of D to print any particular character. Same as logarithm, we will use ampersand. Here we use modulus of D. That's it.
exactly, yeah, yeah, that makes sense. Okay, that is correct. So rather, sorry. Okay, so one more thing, Bharat. Now let's say I have another variable of two. Okay, so now percentage D, then I'm going to say A comma B. This is like something like first come first serve. Like A is going to be printed in the first placeholder. Percentage D is going to be, I mean, like, B is going to be printed in the next placeholder. We'll run this. We'll check for any errors. No errors. Hopefully. Yep. So, um, so yeah, that is it. For float characters, float as in numbers with decimal points, like 5.2, 7.8. Those are all float integers. I mean, like float data type rather. That's a separate data type on its own. So those have percentage F. If you are printing a character, a single character like A, B, C, that will have percentage C. For printing a string, you have percentage S. There are different format strings. They're called format strings, which behave as placeholders in a printf statement. Did you get it?
Yeah, I got it now. Yeah.
Okay, cool.
Thank you. Yeah.
Okay. Now we'll go to the next type of operators. We saw relational. Yeah. With relational, we'll move on to logical operators. This is one of the most important type of operators of all the operators over here, because they can literally they have the ability to link two different conditions to form an expression. Okay. um, yeah, so this is the syntax for and or and not in C. And expects both the sides of the expression to be true, or expects one of the sides to be true and not just inverts the expression. I'll explain it. I'll demonstrate it rather. Now, I'll have to say one more thing before moving on. Mm, let's say, like I've told in yesterday's, I mean, day before yesterday's session, computers can understand yes, I mean like 0 or non-zero. Yesterday I told it as 1, but then they'll understand non-zero better, because that completely depends on the software. In Windows, non-zero is 1, and maybe in, I don't know, in the other OS operating systems will change. So 0 is always false and non-zero is always true. Okay. Now if I say, if I have declared an integer a and a is equal to 2 greater than 3, I want one of you to tell me if this expression is true or false.
It is false.
Yeah, it is false.
So it is
So
0.
what? Yeah, so the value of a will be 0. Okay. Now if I try printing a, then it's going to be 0. Most of there are no errors. So it's going to be 0. Okay. Uh, so the point I was trying to make is, okay, work out to be honest. Okay, great. Now if I was going to say and 3 lesser than 5. So what is the uh, what to say, result of this expression? 3 less than 5. It's true. But then
False
since there
and
is a
true.
false, yeah, false and true, what does it make with an and operator in the
False.
middle?
False,
Exactly.
I think.
So the yeah, it is false. It will be false, and the expression here will be a will be 0. Okay. Uh, there is something called the truth table. Okay. Like maybe last year while learning about AND gates and NOR gates in 12th, we might have come across this. So truth table is literally structuralizing and or not with respect to electronics. So 0 represents off and 1 represents on. Now this is for an AND truth table, and it behaves like a multiplication symbol. So 0 into 0 is always 0. 0 into 1 is always 0. 1 into 0 is always 0, and 1 into 1 is always 1. And similarly, for the OR operator, it behaves like a plus sign. Sorry. So 0 plus 0 is 0, 0 plus 1 is 1, 1 and 1 plus 0 is 1, and 1 plus 1 is 1. Actually, it results in 2, which is 1, 1. The binary code for 2 is 1, 1. That 1 usually gets carried over to the next operation. Here, so yeah. So we just call it as 1 for the sake of simplicity. Uh, yeah. So the point I'm trying to make is, if you are able to convert uh, these relational expressions or arithmetic expressions into zeros and ones at the end while trying to evaluate and or and not during I mean like during the problems which they give in classes, you'll be able to find the answer very easily if you just add or multiply depending on what operator is in the middle. For AND, it's always multiplication symbol. For OR, it's always addition. Yeah. So
But
with that, I'm
Aditya, like in
yeah.
Python, like they have Boolean expressions for like true and false, right? So in C, how do they differentiate between 0, 1 for the Boolean figures and the int figures? Because 0 and 1 is again a part of the int, right?
Mm, I don't think so. They have C has Boolean figures. Wait, I look it up. Don't have, because there's never I mean, there was never the necessity for Boolean in C. You could just uh, go on. Okay, you have a separate header file for that.
Okay.
Exactly, it's not the necessary. It's not as useful as it is in Python, because Python doesn't have a like if you in Python, like if you try giving what I did over here, nah, there it go. Like, if I try doing this in Python, it's a is going to be a bool type instead of an integer type. So I'll need a proper data type to represent it. But then here somewhere it's giving me an int only, so I'm not that bothered with it.
Okay.
That makes sense, right?
Yeah.
Okay. Now moving on. There is something called as hierarchy of operators. Okay. Computers as such don't have mood swings, so they operate straight all the time. They don't care what's coming at them. They don't care about how big the expression is. They don't care how small the expression is. They just operate based on protocol. For us, we use board mass, or as some people may know, ped mass, bracket of division, multiplication, addition and subtraction from left to right. So basically you resolve the brackets first, then you resolve the addition, subtraction, I mean sorry, multiplication, division, then you resolve the addition and subtraction. Here is also almost the similar way, except here you'll have to take into account things like relational operators, what are these called? Ternary operators or conditional operators. I'll come to this, okay? I'll come to this. And also assignment operators. So yeah, the curve bracket, I mean, like the circle brackets literally represent what we did, or what we were trying to parenthesis, and then these define the index of the array. Now let's say we had an array A, and we had to take the value from 1, so that's A of 1, and multiply it by the value of A of 3. So first the C compiler will try to figure out the value of A of, like it will go and pick the, I mean, take the value of A of 1 and A of 3, and then it will multiply. So that will be the first step, right? And then these are our unary operators, plus plus and minus minus, then it will do the rest of the operations. From here to here is something you guys will be familiar with. This is just the modulus or the remainder thingy. This is the division and multiplication, addition and subtraction. All these two and this from left to right. So if you're trying to find the order of which operation to do first, look for it from left to right. And then relational operators, which is these guys over here. So you'll resolve them into zeros and ones, and then you'll have and, or, and these are the ternary operators. I'll come back to that. Then you'll have assignment operators. Now we'll go back to this example. So based on the hierarchy or order of operators which we learned there, what we did was we already had these constants. So from left we solved this, then we solved this, then we solved this, then we have put this value into A. Okay, so let's say subconsciously we followed the order of precedence, as they are called. But then uh, I don't think so. We'll be getting expressions this easy in college. We'll have some big expressions just to eat ahead. When you follow, I mean, like when you try to let's follow those that order and solve this, it becomes very easy. Any questions?
No.
Okay. So we'll move to control structures. Okay. Control structures, the word may sound complicated, but then it's just if else and switch case in this in C. If else and switch case are very similar when it comes to their use cases, but then they're diametrically opposite to each other in use cases that um, there are exceptions. We'll see that. Okay. So if as such is used in situations where you need to execute a set of statements based on a condition once. So when you need to execute a set of statements once based on, sorry, when you need to execute statements once based on conditions, then you use something called as if statement. The syntax is if conditions. So you put the conditions over here. Conditions, then you open curly braces, hit enter, and give whatever statements you have. And then there is an else part to this. Else part is completely optional. Okay. Now again, the syntax is as such statements. Okay. Yeah. Cool.
I had one doubt. So after completing the statements, do we need to give a semicolon or not?
Yeah. Exactly. You'll have to give a semicolon. You don't have to give semicolons here because the block is not complete yet. So within the block, you'll have to give at the end of every executable statement, you'll have to give a semicolon.
Okay, okay.
Cool. Actually, before this, I would like to talk about something else. I skipped. I wanted to do it last class as well, but then I slipped out of my mind. How will you input values from the user to the variables? Okay. For that, you'll use a command called scanf. So printf, you output the whatever is in within the codes to the default output device, that is the screen in this case. Scanf, you take command from the default input device, which is your keyboard. Now let's say I have int a, I'll have to put some value into a which has to be given by the user. So I'll say colon %d, and I'm going to say ampersand a. Okay. Now what I'm actually saying to the compiler is, I mean, like, what is C telling the telling the OS is, take the value which he types, which he or she types over here, and put it to the address of A. A is the address of the memory location. When you say ampersand A, I'm literally accessing the memory location itself. You get the point, right? Like, I'm telling the memory controller to write this memory over there. Now, if I give A as such, there is no, I'm trying to read the value of A. In a scanf command, that will be a syntax error. I'll have to give ampersand A such that I access the memory of the memory location where, which has the address A, and write data into it. So then we'll just print it. HD A simple. Cool.
But earlier, when we were like rewriting the value of a, we didn't use the ampersand, right? We just uh, when we are incrementing it, then why?
Okay. That is yeah. Scan, if I'm inputting the value, I'm giving it from a different input device. Those calculations happen internally, right? So I don't have to be bothered with changing anything else other than the value of a. Like, the computer doesn't have to be bothered because it knows where exactly a is and where exactly its address is. But then when I'm saying this, I'm asking it to go to the particular. I mean, I am accessing, like, this keyboard is accessing the memory location of a, and then writing values to it. Does that make sense?
Hi, yeah, sort of.
Okay. Okay, I'll try to find a better explanation in next class and come back. Is that all right?
Yeah. In the meantime, even I will search for it.
Okay, cool. Yeah, so we will run this, and I'll say one. So it prints the, I mean, like, so it literally that's what it says. I take input the value of a and then print it. Now we'll go to if command. It is before itself, and then I forgot. Sorry. If, and we have conditions, and then enter. We'll have statements to execute. Okay. We'll write a simple program rather. Uh, Eligibility to vote or not. Okay, that's like the hello world of every if statement. Like in every language that I've learned, the first if statement program is if I'm eligible to vote or not. Now I'm going to say scanf. One more thing. In scanf, you can't give your own command as such. You can't say enter your number %d. You can't do that in scanf. The reason being, it's purely input command. You can't output with it. So like if you try inputting it, it'll either give you an error because that depends on the component. It'll either give you an error or it won't let you write anything to it. So I'll have to say printf enter your age. Now when I do that, I'm going to say \n. I'm sorry, \n. What \n does is it takes the cursor to the next line. Okay. Now I'm going to say scanf. Scan and age. Now the condition should be I should be either equal. My age should be either equal to 18 or greater than 18. So a must be greater than or equal to 18. It's true. I'm going to say printf. Value. I'll come out of the block and I will type else because I have an else statement over here. I'm going to open a control block and say printf. They are not. I'll just copy paste this. So the logic is straightforward. I'm just checking if my age is greater than 18 or not. I'm running it.
Semicolon, bro.
Shit. I prefer a semicolon. Great. Yeah. Ah. Oh, I didn't put ampersand.
No, stop the program. Like there's a red button. No?
I'll try explaining the reason for this ampersand in a different way. Okay, there is something called pointers in C. Okay, this pointers you'll be able to retrieve the exact address from the memory controller of your memory itself. Like that level of accessibility is not possible in other languages, but then it's possible in C. When you're seeing ampersand of A, this format retrieves the address of A from the memory controller itself. Like there is a certain code given to every slot, every grid in in the memory. So like when you're saying ampersand A, you're accessing that particular slot directly. So when you type, you're directly writing it to it instead of telling the memory controller to write to it. Does that make sense? Mm, yeah. Okay. Moving on. So I'll enter my age, like it's 12. It's going to say I'm not eligible to vote. I'm going to do it once more. I'm going to say I'm 34. I am eligible to vote. So that is the use of else. Okay. Now I can do something interesting. I'm going to say else if. I'm going to introduce another condition to this. And in else if, what I'm going to do is I'm going to say else if age is lesser than 18 and age is lesser than 18 and uh, let's say 18
Greater than 16, something like that.
okay, yeah, greater than 16, that will also work. Is greater than 16, right? So now you can say printf uh, to have 2 more years, to have to wait for 2 more years.
Aditya, not two actually. Just keep it for a little more, something like that.
It doesn't matter. Okay, what I was trying to do is I was trying to do something called as generalizing the program. So like if I say if I'm A is lesser than 18, I'll say instead of 2 over here, I'm going to say percentage D. After saying percentage D, I'm going to say 18 minus A. Okay. Now what this is going to do is, doesn't matter, like even if I'm 0, yes, it's going to print 18 over here because A is 0 and this expression will be evaluated to 18 as such. Okay, then in that case, we don't even need this, right? Or you could just give this in the else part itself, like instead of giving it as an elif. Right, semicolon. Pretty sure I'll lose mark for semicolons itself. So my age is 12. Yeah, I have 6 more years. I have to wait for 6 more years. This is something called as generalizing the problem. So I'll, yeah, it makes it more user friendly. At the same time, it works for every value of a. Uh, I can give another condition over here to say that if it's greater than 0, like if I'm minus 3, like I'm yet to be conceived, so it doesn't actually work in that way, right? So I can give a condition like a is greater than 0, and a is greater than okay, like if it's greater than point is like here I can a is greater than 0. Because here, if the command turns out to be false, it's going to come over here and check over here. Na? So if I say minus 3, here it will turn out to be false, and it'll, in the else part, I can give something like type a positive integer. So that is something you can do. You can can continuously update to make the program better. And that's what I'm trying to do.
Yeah, but I think the
Now,
condition check should like happen in the beginning. Like check if check if it is actually an age. It is then under that if statement put in another if like a nested if. I think that is a better idea than putting like continuous if and else and stuff.
readability wise, nested is better, but then this is more efficient.
Oh, is it?
Like I don't have to open two blocks, right? Like nested if, I mean, like usually the lesser statements you write, the better it is.
Ah, okay.
Yeah, like nested ifs also work. There are a lot of places where nested ifs is a better solution, but then sometimes it is just wonky. I'll just do switch, or should we do it in the next class?
I guess we can do it like switch has multiple if else condition, no?
Yeah.
Then we can do it next time. Yeah,
So
and today I guess there are many new people.
it's almost
From
like the people who didn't come yesterday are there today.
from CSE itself, no? I guess Ananya shared you the link, right? Uh, Anu, Anushweta, Sai Chandrita. Ananya shared you the link, right? Group.
Which the one you're having?
Yep. To the accused thing,
Yeah,
basically.
yeah. I got it from there.
Ha. So see, this is just an experimental idea. So like, how are you liking it? I don't. We are just like experimenting with stuff right now. We don't know how.
I've just joined today and I think it's good. Something new.
Yeah, I mean, it's not just Aditya teaching actually. Like
Okay.
any like students, basic idea is wait, I'll explain the entire thing again. So the basic idea of ETUs is student teaching other student. So basically, we get to learn from your own classmates, which means even you can conduct your own like session. Uh, and the basic idea is like to you conduct sessions to improve your knowledge on it. Like if you want to test yourself, if you like actually understood it, then conduct a session, like teach people, and if from the doubts they ask, maybe you can, uh, you know, get where
Okay.
you
So
are.
basically it's helping each other, right?
Uh-huh.
Okay.
Most importantly, helping yourself. That is the idea.
Okay.
Uh, And I guess only like 7 or 8 people join. Hey, we should expand actually, like to the entire first years.
Abhijit, step by step, step by step.
Like even I thought step by step, but then uh,